Hello, everybody. Welcome to my talk. I wanted to share a little story with you, which happened to me while I was hitchhiking with Marvin and Eliza a few weeks back. And you know what happened? So Eliza, very soon during the hitchhike, started to talk to the train computer, to other laptops, to everything that she could talk about. And Marvin all the time said, "Ooh, it's not secure. We have to do something." And he was really upset about the safety and security that we were running in. And then I finally asked Marvin, so what would you use to secure the communication channels? And he said, yeah, well, you have to use Neuropil. And I said, what is Neuropil? And he started and said, it's a very small library. It's a C library that you can install on any device. You can use it as a library in an application. And it's working in a decentralized, scalable way. And it's doing security, and it follows a security and privacy first by design approach. If you would like to compare it, he gave me like four different protocols, and I don't know if you have heard of them. I'm not that technical. So who of you have heard of OpenSSL? That should be fine. MQTT, also. Virtual private networks. Okay, and last but not least, WeaveNet. Nobody. That's astonishing. And then I said, why do I need this strange combination of protocols and stuff? And he said, okay, I will give you an example why you need it. If you take, for example, a factory and you have a robot arm, then you have to be aware that as soon as you add a connection, an external connection, the security context of the whole factory changes. So if you add a connection to an insurance company, you have to review your whole security concept. And he said, you could do it the other way around. You can follow directly a very high security approach, and then you don't have any problems later. If the robot arm moves to a different factory, you would like to have very small setup times, but still have a high security. And we can focus more on the robot arm and take a look at its interactions with the robot company on the maintainer on the left side. And basically you have the robot arm, and he needs obviously some information about the product it has to produce. For example, a cell phone, right? So to this cell phone product information, there is a data owner. Now, the robot doesn't have a connection to a second robot, so he uses this cell phone to store some information, to push it to a separate robot arm. Nobody else should read this data, so he will encrypt the data for the second robot arm. Unfortunately, the second robot arm discovers there's something wrong in the production process. So he shares this data with the maintenance engineer, and suddenly the context has changed, and you need to do a group encryption actually with the robot arm 1 so that the maintenance engineer and the robot 2 can read this data. And if the maintenance engineer would like to repair something, he has to call out to the robot company to get an authorization. The robot company has to talk to the robot 1 and say the maintenance engineer is now allowed to alter some data. And finally, then the maintenance engineer can fix the production procedure of the robot 1. So what's important on this picture is that there are 3 different data sets, and each data set has a different data owner. And for each data owner, you have different authorization and authentication rules. Let me have a look at the note that Marvin gave me. So these are, we just scratched the surface of possible interactions that we have. You could say, you could place the robot arm, you could replace it with a medical device, and the factory with a hospital. And then you will see how critical the encryption and or at least signing of data is, and how important data ownership is. If you ask what could go wrong, then you will see a lot of things will go wrong or can go wrong. Producing wrong products or operational interruption is very critical, at least in the industry. So you should really care about security first for your production lines. So what's on top of what I already said, what is Neuropil? So Neuropil is a networking library which is giving you digital identities. And we annotate these digital identities with attributes. So we are exploring attribute-based distributed security concepts and also attribute-based encryption, which is new in the field. We cover, we do a lot of things to obfuscate our protocol metadata. And we also focus on partly encrypting payload data to protect some parts. What you can do with it in the end is that you are able to set up very easily a virtual private network per data object. So you can you have a very fine detail of sharing data with other persons, but it just takes seconds to set this up. So at the end of our trip, I said, Marvin, if this is all that secure and everybody should use it, then it doesn't pay out to keep it in the secret. You have to make it A, open source, and B, you need a security peer review. And that is basically also the reason why we are here. So our new release is now available on GitHub. And we are looking for cooperations or for your feedback so that we can improve the protocol and that we can take the next steps and grow, hopefully, an open source community around our protocol. That's already from my side. Thank you for your attention.
Thank you. So we have plenty of time for questions. If anybody has a question, please raise your hand. I'll bring you the mic. No question? Well, thank you then.
If you have any questions, I'm outside and you can see me on my shirt.